Welcome to ICAN Academy YouTube channel. In this lecture, I want to examine probability. If you are coming across my lecture for the first time, please like the video and also share it with others. If you are a returning subscriber, I say thank you for being part of this channel. What is probability? Probability is a statistical concept that measures the likelihood of an event happening or not. The studying of likelihood of an event happening or not. I repeat, probability is a statistical concept that measures the likelihood of an event happening or not. I want you to know that probability take any number between 0 and 1. It takes number between 0 and 1. So, the probability of element 0, probability of 0 means it is certain that the event will not occur or happen. So, if the result of your probability is 0, that means it is certain, it is 100% sure that this event or that event will not happen. Then probability of 1. If the result of your probability is equal to 1, it means it is certain that the event will occur or happens. So when the event will certainly happen, or when it will happen, when it will occur, that means the result of the probability will be 1. So we want to look at the definition of terms used in probability. Definition of terms. Number 1 term is an experiment. An experiment. An experiment. This means performing an act which involves unpredictable outcomes. When you perform an act, you are not sure of whether the outcome of your experiment, you are not sure of what it will be. That is an experiment. An experiment means performing an act which involves unpredictable outcomes. That is, when you perform an act, you are not sure, you are not certain of what the possible outcome will be. That is an experiment. Example of an experiment include 1, throwing a die. If you throw a die, we have 6 possible outcomes that may be obtained. You may have 1 showing up, you could have 2, you may have 3, you may have 4, you may have 5, you may have 6 outcomes, 6 possible outcomes. Out of these 6 possible outcomes, you don't know which one will actually show up. 3 may show up, 4 may show up, 1 may show up, 2 may show up, even 5 or 6 may show up when a die is thrown. So the act of performing that experiment, when you throw a die, in which you don't know the possible outcome that may show up in your throwing of a die, that act is called an experiment. When you toss a coin, the possible outcome could be head showing up or a tail, but you don't know, you are not certain of what the outcome of your tossing a coin could be. So the process of doing that, or the act of doing that, is called an experiment. Number 2, we have an outcome. An outcome. An outcome. An outcome is the one of the possible results that can happen in a trial of an experiment. One of the possible results that may happen or that can happen in a trial of an experiment. When you perform an experiment, the possible result that may happen is called an outcome. Just like when a coin is tossed, I said the possible outcome could be head or tails. So these are the results obtained. If head shows up, that means the one that show up is head. That is an outcome of tossing a coin. Number 3 term which will be examined is sample space. Sample space. Sample space. Sample space is the list or set of all possible outcomes of an experiment. The list or set of all possible outcomes of an experiment. I want you to know that each outcome of an experiment is called sample point. Each outcome of an experiment is called sample point. Number 4 term which will be examined is an event. An event. An event is a collection of sample points. The collection of sample points which have certain quality or characteristics in common. The collection of sample points which have certain quality or characteristics in common. Example include when a coin is tossed once. If a coin is tossed when a coin is tossed once. If you toss a coin once, the sample point could be having a head showing up or a tail showing up. So that means this is one sample point, this is another sample point. That means we are having 2 sample points. That is 2 sample points. 2 sample points. So when a die is tossed once, this is another case. When a die is tossed once, the possible sample point could be having either of 1 showing up or having 2 outcomes showing up or having 3 or 4 or 5 or 6. These are the possible sample points. That means altogether you have 6 sample points. You have 6 possible sample points. Number 3, when a coin is tossed twice. 3, this is another case. When a coin is tossed twice. You toss a coin twice, what are the possible sample points you may have? Remember, if you toss a coin, you may have head showing up or tail. This is first coin or tossed. The second one may be having head or tail in the second coin. Then both together you may have head in the first one and head in the second. Head. Or having head in the first coin and tail in the second. Head, tails. Or you may have tails in the first coin and head in the second. So tail, head. Then tail in the first one and tail in the second one, which is tail. That means altogether the sample points you have head, tail, head, and tail. These are the possible sample points. That means you have 4 sample points altogether. 4 sample points. 4 sample points. These are the possible outcomes. Number 4, when 3 coins are tossed. When 3 coins are tossed, or tossing a coin 3 times, or tossing a coin 3 times. When 3 coins are tossed once, or when you toss a coin 3 times, the possible outcome could be having head showing up in the first, tail in the second. Then you may have head in the first, and in the second, tail in the second. Then this is first coin, this is second coin. The third coin, you may have head and tails as well. So what are the possible combination now? You may have head in the first, head in the second, head in the third. Head, head, head. Then you may have head, head, tails. Head, head, tails. You may also have head, tail, head. Head, tail, head. Head, tail, head. Then you may have head, tail, tail. Head, tail, tail. Then in the first one, you may also have tail. Having head in the second and head in the third. Tail, head, head. You may also have tail, head, tail. Tail, head, tail. Then you may also have tail, tail, head, tail, tail, head. You may have tail, 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 tail. Now let's count it. 1, 2, 3, 4, 5, 6, 7, 8. 8 sample points. 8 sample points. That is, the sample point could be head, 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 tail, head, tail, head, head, tail, 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 head, head, then tail, head, tail, then tail, head, tail, then tail, head, tail, head, then we have tail, tail, tail. These are the possible sample points. You should try and generate these sample points yourself. Number 5. When a coin and a die are tossed. When a coin and a die are tossed. So when you toss a die, the possible sample points are 1, 2, 3, 4, 5, and 6. And if you toss a coin, the possible sample point could be, you may have head, the possible outcome could be head or tails. So if a die and the coins are tossed now, the sample point could be head 1, head 2, having head in die in coin and tail in die. Head 3, head 4, head 5, and head and 6. Then you may have tail 1, tail 2, tail 3, T4, T5, and T6. That means altogether you have 6, which is 6 by 2, which is 2 by 6, which is 12 sample points. 12 sample points. Then this is another case, number 6. When 2 coins and a die are tossed. When 2 coins and a die are tossed. when two coins and a die are tossed. Remember, if you toss a die, you have 6 possible outcomes. Outcomes could be 1, 2, 3, 4, 5, 6. That is, if you toss a die. And if you toss a coin, 2 coins, no 2 coins, you have 2 coins. If the first coin you may have head, tail. The second one, head, tail. That means you may have head, tail. Then you may have tail, head, and tail. 4 possible outcomes. So that means the sample points are head, tail, head, and tail. Now, these are 2 toss of a coin, and this is a die. When 2 coins are tossed, when 2 coins and a die are tossed, 2 coins are tossed, you have this, and this is for a die. So you may have possible combination could be head 1, head 2, head 3, head 4, head 5, head 6. Then you may have head, tail 1, head, tail 2, head, tail 3, head, tail 4, head, tail 5, head, tail 6. This could be tail head 1, tail head 1, tail head 2, tail head 3, tail head 4, tail head 5, tail head 6. This could be tail 1, TT2, TT3, TT4, TT5, TT6. Now, this is 1, 2, 3, 4. 4 by 1, 2, 3, 4, 5, 6. 4 by 6, which is equal to 24 sample points. 24 sample points. Number 7. When 2 dice are tossed. When 2 dice are tossed. If the first die you have 1, 2, 3, 4, 5, 6, and the second die you have 1, 2, 3, 4, 5, 6. The 2 dice now, you may have one in the first, 1 in second, 1 in the first, 2 in second, 1 in the first, 3 in second, 1 in the first, 4 in second, 1, 5, 1, 6. You may have 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. You may have 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. We have 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. We have 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6. We have 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, and 6, 6. Now, 1, 2, 3, 4, 5, 6. 6 by 1, 2, 3, 4, 5, 6. 6 by 6, which is equal to 36 sample points. Probability of an event E. Probability of an event E to happen equals to number of the required outcomes of the required outcomes over total number total number of its possible outcomes. This is the general formula for solving probability. If the event to happen is A, the formula is number of the required outcomes over total number of its possible outcomes. Now let's take questions as work example to further deepen into the topic. Example 1. If a fair coin is tossed once, what is the probability of obtaining head? Now let's have the solution to the question. Solution. So this possible sample points are, if you toss a coin once, only one coin once, you may have head or tails to show up, or tail to show up. That means you have two possible outcomes, which is two outcomes. Then what is the probability of obtaining head? Probability of obtaining head. How many head is showing up? So know the formula. I said the formula is number of required outcome, which is number of head over total number of total possible outcome, which is total sample points. Total possible outcome. So this will give you the probability of obtaining head. Number of head over total sample points. The number of head you have that show up is one head out of two sample points. So that is the solution to the question. Example 2. If a fair die is rolled once, what is the probability of obtaining an even number? Let's have the solution. The sample point in a roll of a die could be any of these: 1, 2, 3, 4, 5, 6. What is the probability of obtaining even number? Probability of obtaining even number. That will be total. That is number of even numbers. That is number of required outcome. That was the formula I gave you. Number of even numbers over total number of possible outcome. That is total sample points. Sample points. Even numbers here. No, even numbers are numbers that can be divisible by 2. So even numbers from this include 2, 4, and 6. Number that can be divisible by 2 without leaving a remainder. So probability of obtaining even number now. How many even numbers do we have? Even numbers. We have 3 even numbers. Out of, the sample point, we have 6 sample points. 6 sample points. So 3 out of 6 outcomes. So 3 in 3, 1. 3 in 6, 2. So we have 1 over 2 or 0.5. That is the solution to example 2. Example 3. A ball is drawn at random from a box containing 8 green balls, 5 yellow balls, and 7 red balls. Determine the probability that it is A, green, B, yellow, C, red, D, not green, E, green, or yellow. Let's have the solution to the question. What are the possible sample points? We have sample points. Some points. We have a ball is drawn at random from a box containing 8 green. The green balls are 8. Yellow balls, 5 yellow balls, and 7 red balls. Total 8 plus 5, 13 plus 7, 20 balls. 20 balls. This is the sample point. In the requirement A, or in the A part of the question, you have to determine the probability that it is green. Probability of obtaining green. Probability of obtaining green. That is number of its required outcome. And how many are green? We have 8 green. Out of, what is the total? 20. 4 in 8, 2. 4 in 20, 5. We have 2 over 5, or 0.4. That is the solution to A part of the question. Then B, you have to determine the probability that it is yellow. Probability of obtaining yellow balls. How many of the balls are yellow? We have yellow 5. 5 yellow balls out of 20 balls altogether. So 5 in 5, 1. 5 in 20, 4. 1 over 4, or 0.25. That is the solution to B. Then C, probability that it is red. Probability of obtaining red balls. How many of the balls are red? We have 7 red balls out of 20 balls altogether. So the probability of obtaining red, we have 7 over 20. Then D, probability that it is not green. Probability that it is not green. Probability that it is not green. So when it is not, the opposite probability will be equal to 1 minus probability of obtaining green. When it is opposite of something that happens. So when you want to oppose it, you have 1 minus probability of that event. 1 minus probability of obtaining green, we have 8 green balls out of 20 balls. You have, which is equal to 1 minus 8 divided by 20. That gives us 0.4. 1 minus 0.4, that gives us 0.6. So the probability of obtaining, probability that it is not green, probability that it is not green, equal to 0.6. If you like, you can work on the fraction by simplifying this fraction. Alternatively, probability that it is not green. You know, you have 3 balls. 1 green, 8 greens, 5 yellow, and 7 red. Probability of not green. If it is not green, that means it could be probability of yellow, or probability of red. If it is not green, it could be yellow or red. Probability of obtaining yellow. How many are yellow? 5 out of 20, plus how many are red? Probability of red. All in probability is plus. How many are red? 7 out of 20. If you simplify this fraction, LCM is 20. So we have 5 plus 7, which is 12 over 20. You can reduce it to its lowest form. 4 in 12, 3. 4 in 20, 5. So probability of not green equals to 3 over 5. 3 divided by 5 will be 0.6, or 0.6. The probability of green or yellow. Probability of green or yellow. That means it is the same as probability of obtaining green or Probability of obtaining yellow. Remember I told you all in probability mean plus. Probability of obtaining green. How many are green? We have 8 green out of 20 balls. Or is plus. Probability of obtaining yellow. How many are yellow? 5 out of 20 balls. If you simplify this, the LCM is 20. So you have 8 plus 5. 8 plus 5 equals to 13 over 20. Therefore, probability of obtaining green or yellow equals to 13 over 20. So that is the solution to the question. So we will stop this video here. In my next video, I will examine the additive law and the multiplicative law of probability. Please drop the love emoji, like the video, and also share it with others. Thanks for watching the ICAN.